Hi guys, welcome to Education Spot. So in this video we're going to be doing mathematics, focusing on the topic of Euclidean geometry, the grade 10 content. But in this video we're not going to be doing any calculations. It's just to give you like a basic introduction to what Euclidean geometry is and give you like basic information for you to boost your confidence and your skills into to mastering this thing called Euclidean geometry. So in this video we're going to be talking about a lot of stuff, but hopefully at the end you're going to know more about polygons, what are polygons, congruent shapes, similar shapes, and the types of triangles we have. It sounds like a lot, but it's the information that you need to know in your grade 10 stuff. Okay, so let's go on to the beginning of the lesson. We're going to start with polygons. Okay, so polygons sounds like a huge word, but if you type it in your Google, it's going to give you the simplest answer. So what I found was, okay, basically they define a polygon as a flat plane figure which is bounded by straight lines, and then they gave me examples of squares, parallelograms, triangles, and then it says circles are not included. So you need to take note of let me try and use yellow looks nice. Okay, let me try and use the coloring. It says circles not included, right? Okay, so it says it's a flat plane. A flat plane is what? A 2D figure, right? Which is bounded by straight lines. So it means it's enclosed by straight lines. And then looking at, it's not visible. Let me try and use red. We're going to call this our figure A, and then we're going to call this our figure B. So it says a flat plane which is bounded or enclosed by straight lines. Here you see we have a figure 2D shape which is enclosed by 3 straight lines, and then since it's enclosed by straight lines and the straight lines are closing the figure, it means it qualifies as a polygon. Even this one, it qualifies as a polygon because it has 4 sides which are enclosed by straight lines. So the problem with B is that we only have one straight line, and then we have this curvy thing right here, which is why it says circles are not included, and this is a semicircle. It does not necessarily qualify the statement here which it says polygons are flat plane figures which are bounded by straight line, because this one only has one straight line and a curved line, right? So let's say let me think of another shape. Let's say we had a funny looking shape like this one. Would you call this a polygon? You can pause this video and think about it. Okay, I'm gonna give you, okay, it's gonna be a bit awkward, but let's move on with the program. This does not qualify as a polygon because the figure we have here it looks like it has one straight line, which is this one over here, and then this one is curvy. But the problem again is that this figure is not enclosed by a straight line because we have 2 openings, which is this side and this side right here, right? So it doesn't satisfy the sentence which is given here in the beginning. So let's remove all the stuff and move on this thing. Right there. And then we're going to go on to the sum of all the interior angles that we have in a polygon. Like you're seeing these figures right here, and you're thinking to yourself, oh my god, what is this 184? What is this 364? What is this 724? Now, this statement says the sum of all interior angles of a polygon is equals to this number right here, and then I simplified it to 180 by taking out the common factor, which is 180. You just have 180 and minus 2. So let's make an example of a triangle. We have this 180 which is given, and then the n signifies the number of sides a polygon has. So a triangle has 3 sides. We're going to use 3 minus 2. my 3 doesn't look nice, which is what equals to 1, right? And then it's going to be 180 multiplied by 1, which is 180 degrees. Now, for instance, if we were to take the square, right? A square has 4 sides, so the n is going to be 4 minus 2, which is equals to what? 2, right? And then it's going to be 180 degrees multiplied by 2, which is going to give you 360. Same with the rectangle, it has 4 sides, and then your n, you're going to put your 4 minus 2, and then it's going to give you 2. Then it's 180 multiplied by 2, which is 360. And then basically at this stage, that's all you need to know about polygons. Let's move on to congruency. Now, it sounds like a huge word. So firstly, you need to break down the word into understanding like the concept of the word correctly. By congruent, what do we mean? Like, if you check your dictionary looking for congruent, not congruency, looking for congruent, not congruency, check your dictionary, you type it in Google, it's going to tell you that congruent means to be in agreement or to be in harmony. So it also gives you a definition that in geometry you just say something that is congruent, it means it's identical, right? Okay, now let's apply that basic definition into mathematics. Now let's say we were given 2 figures, no? What would it mean for these 2 figures to be congruent? Now, by definition, they must have all corresponding angles to be equal to each other, right? Now it means if I had, let me use a pen, red pen, black pen. Okay, let me use a red pen, this one. Looking at this figure here, we're going to call this triangle number 1, triangle number 2, right? Okay, it means all corresponding angles are equal. So we have this angle here, which is similar to this, oh, it's not similar, it's identical to this angle here. And then we have this angle here, which is identical to this angle here. And by default, the angle right here is going to be equal to the angle right here, right? Which means both these triangles are congruent to each other. Now, another definition says all the sides, or the lengths of the sides, must be equal to. Now, looking at this diagram here, or we can look at this one, you have 2 strikes here, and then you have 2 strikes here, which means this triangle and this triangle are the side and this side are equal. And then you have 1 strike here and 1 strike here, which means this side and this side are equal. And by default, it means this side is equal to this side, right? Now, looking at these 2 figures, you can see that, okay, these things look the same, but they are not orientated the same, or they are not placed in the same direction. Now, congruency doesn't take the orientation into consideration. It says after translation, reflection, rotation, a shape and its image are congruent. Now, looking at this one, you can see that this triangle was rotated anti-clockwise and placed face down. Like, if you can take your phone or whatever device that you're using to view this video, you can put this thing upside down, and then you're going to see that this image is the same as this image, whether it's upside down or downside up. And then let's move on to similar shapes. Now, by definition, looking at the word similar, it means something are alike. They're not necessarily identical, but they are alike. So taking that into consideration and applying that definition into what we're dealing with here, we're going to say, okay, similar shapes have the same size of corresponding angles, right? which is the